Hi everyone. So you're going to learn today lesson 3.3 transformations of functions day 2. But just to review from day 1 what you know already. So in day 1 we explored transformations of functions, in specifically the translations, vertical translations up and down. And we looked at the x squared function. So looking at the original function, f of x equals x squared, g of x equals f of x plus 2. Now f of x here is just the name of the function, okay, not to be confused with the actual math part. When it's written like this, remember this is function notation. This is just saying take function called f and add 2 to it. And rewriting it with the math, I took the function named f of x, which is x squared, and I added 2 to it. Okay, so then we're going to graph f of x. You fill in the table for f of x. We filled in the table for g of x. And then this basically we plugged in those values in the f of x function and the x squared. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0, and so on and so forth. This was the original function. And then we wanted to explore what does adding 2 on the outside of the function do. And then, so you're going to square and then add 2. So negative 2 squared is 4. Add 2 to that, you get 6. Same thing for negative 1 squared is 1. Add 2 to that, you get 3. We filled in the table and we graphed the translated function. And you can see that adding 2 in the equation moves the graph, moves every y value up by 2. So 4 went to 6. 1 went to 3. 0 went to 2, and so on and so forth. Graphically, it shifted up 2. Okay, every point here shifted up by 2. Okay, that's a vertical translation. All right, then we looked at the linear function. Linear function, we started at x, and then now we said, okay, take f of x, the function named f, and then subtract by 3. So I rewrote it with the math. The function named f is just x, so I took x minus 3. Okay, and then we plugged in those values. So negative 2 in the f, negative 2, you plug in negative 2 for x, you get negative 2 for f of x, which is the y. This is the corresponding y. Okay, plug in negative 1, you get 1. Plug in 0, you get 0. So that's the original function. Then the effect of subtracting 3 is going to be moving the original function down by 3. So each one of those points is vertically translated down by 3 units. And that's a transformed function. Okay, which you can see here by plugging in negative 5 in here. Plugging in negative 2 in this x. So negative 2 minus 3, you get negative 5. Negative 1 minus 3, you get negative 4. Negative 1 minus 3, negative 4, you get 0 minus 3, negative 3, 1 minus 3, negative 2, so on and so forth. So this subtracting 3 changes the output, the outside of the function. Notice here for the same x values, these are exactly the same x values. I did not touch the input. Okay, the output changed. The output changed by 3, so the function moved down 3. And then you learn that essentially that's the effect for adding a number on the outside of the function. Okay, so let f of x be any linear function, so the original. If I add a number on the outside of the function, that means the y values are going to change. So those are going to go up or down. If it's adding a number, you're going to go up. If you're subtracting a number, you're going to go down. Okay, and that's what you learned on the previous day. So looking at this function, this is the original. What changed? Well, the only number that I see that changed here is the 3. Okay, I only see that the 3 changed. And the 3 is on the outside. See, it's outside of those parentheses. That means I know when I graph it, it's going to go, my original function is going to go up by 3 units. Okay, and that's what we answered in the previous day. So today you're going to look at horizontal translations, left and right, and how that works. All right, so let's look at that. So open your notes to 3.3 transforming linear functions day 2. And let's explore what happens here when we add the number on the inside of the function. Okay? So we're going to start with exploring a non-linear functions, the x squared, just because it's easier to see that the translation when we do that with that graph. Okay, so we're going to start with the original x squared. Okay, and then what we're doing here, we're evaluating, finding the value of y when we put in -2 for x. So put -2 for x and square it. -2 squared is 4. Okay, -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. Okay, now let's look at g of x. What is g of x? Well, let's take a look. G of x, we're using the naming here, the function called f, but I'm changing the inside. Look at the input. This is the input. Okay, I'm saying don't use x for the input anymore. Use x minus 2 for the input. So that's like telling me what to do. Let's translate that into the math part. Okay, so the math part is the right side of the equation. It's saying take this x and replace it with x minus 2 and then square it. So I am changing the input here. And let's see what that does in the graph. Okay, so we have g of x here, which is x minus 2 squared. Okay, and then we're going to graph it here in a bit, but let's fill in the table and notice what's happening. Okay, we are changing the input. So evaluate. We'll do -2, put -2 in for x, subtract 2, and then square the answer. -2. Okay, and then subtract 2, which is -2, and -4, and then square the answer. So we get -4 squared, which is 16. Okay, we will evaluate for all of those the same way. So plug in -1 for x, subtract 2, you get -3, and then square it, and you get 9. Okay, likewise here, 0 minus 2 is -2, square it, and you get 4. Same deal here, 1 minus 2 is -1, square it, and you get 1. 2 minus 2 is 0, square it, and you get 0. 3 minus 2 is 1, square it, and you get 1. 4 minus 2 is 2, square, you get 4. And then 5 minus 2 is 3, and then square it, and you get 9. 3 squared is 9. All right, now this is very important. We are changing the input here. Okay, we are changing the input, meaning the output stays the same. Okay, the x value is the input. The x value is the input. Okay, meaning the output stays the same. Okay, so the output, which is the y values, remain the same. Okay, changing input, output remains the same. So how are we going to look at the table and use this fact? Okay, I'm going to look at where the output is the same in the table. In the same order, I want to look for the same order where the output in the two tables is exactly the same. Okay, I'm going to start here with number 1 because I want the same order, or even 4. 4, 1, let's look at 4, 1, 0, 1, 4, 9. Where do you see that in exactly the same order in this table? Okay, so we're going to highlight the output. 4, 1, 0, 1, 4, 9. Where is exactly the same order in the other table? Well, I see it right here. 4, 1, 0, 1, 4, 9. this is where the output exactly the same. Okay, now let's look at the input and see what changed. For the same output here of 4, my input went from -2 to 0. What happened? Yes, it went 2 to the right, this way. Okay, let's look at the output of 1. Same output, we went from -1 to 1. Same output, the corresponding x, we went from 0 to 2. That's 2 this way to the right. Okay, for again, the same output of 1, we went from 1 to 3. Likewise, when we went from 2 to 4, so on and so forth. Let's graph these and see how that's shifted. Well, it went 2 to the right. Okay, so let's see it here. So let's graph that -2, 4. That's the original. I'm doing the original in pencil. Okay, -1, 1, 0, 0, 1, 1, and then 2, 4. This is the original graph. Okay, let's look at the matching graphs here. So we're starting at 0, 4. Okay, 0, 4. So I'm just going to graph the pieces I highlighted. Okay, 1, 1. Look at this point went from here, 2 to the right. I added 2 to the right. Okay, same thing here. This went from here to here, 2 to the right. Okay, now let's graph. So I got 1, 1. Let's do 2, 0. Where's 2, 0? This point went 2 to the right. Okay, 3, 1 right here. This point went 2 to the right. And then 4, 4. This point went 2 again to the right. This is my transformed function. Okay, well, wait a minute. Let's look and compare that to the equation. Okay, look. The equation says x minus 2, but we went right by 2. Yes, we will go right by 2. So when the input changes, it actually works opposite of the way your brain wants to think. So for the horizontal translations, if it says -2 in the inside, you're actually going to go right 2. Okay, so this on the inside caused a horizontal translation right 2. Okay, right 2. So it's the opposite. It's the opposite of what you see in the equation. It's the opposite of what you see in the equation. Opposite of equation. And that's how the horizontal translations work. Why? Because of what I just showed you. Because when you change the input, we're looking at where the output remains the same. So where the output remains the same, compare the input, and it goes to the right. The opposite of what the equation says. Okay, let's do this one. Okay, be sure you are still following along and filling in those tables. All right, we're looking at the original. This one is a linear, so it's going to be a line. Let's put some values. Okay, the goal is with the translations, we're not going to be filling in tables all the time. The goal is to be able to look at the equation and figure out what's happening. So you tell me what's happening. Vertical translation, horizontal translation, up, down, left, or right. Okay, without having to do the tables. But when you're learning it at first, we want to look at the tables so you can see what's happening. Okay, so f of x is x minus 1. G of x takes the original function, f, okay, and changes the input. So now it says, okay, instead of x, use x plus 3 instead. So I'm changing the input again. So this is the naming and telling me what to do. Now the math part, look what happened here. This x changed to x plus 3. I'm changing the input, and then I'm adding 1. Okay, let's fill in the table of values for both of these. So this one is x plus 1. G of x is x plus 3 plus 1. Okay, so if I plug in -2 in here, I get -2 plus 1, which is -1. Plug in -1 plus 1, you get 0. Put in 0 plus 1, you get 1. 1 plus 1, you get 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. All right? Let's fill in this table. We're going to do -2 plus 3 and then add 1. -2 plus 3 is 1 and then add 1 and you get 2. Same thing here. Okay, -1 plus 3 and then add 1, so we get 2 plus 1 and we get 3. Same thing here. 0 plus 3 is 3 plus 1 is 4. 1 plus 3 is 4 plus 1 is 5. 2 plus 3 is 5 plus 1 is 6. 3 plus 3 is 6 plus 1 is 7. 4 plus 3 is 7 plus 1 is 8. All right. Now I want to look for the same order on the output. Where is the output matching? It looks like I start at 2 here, so we're going to look at 2, 3, 4, 5 in the original function because I have exactly the same points here. 2, 3, 4, 5. And let's look at what happened to the corresponding x values. Same y value, okay, that x went from 1 to -2. Same y value here, that 2 went from 2 to -1. For the 4, the corresponding x is 3 and it went to 0. So we're at 3 and we went to 0. So it went left. All of these points went left 3 points. Okay, look at the 5s. We went from 4 to 1. That's 3 to the left. How does that compare to the equation? Yes, that's right. This is saying plus 3. I'm going to go opposite. 3 to the left. That's how horizontal translations work. Okay, so let's graph this. I'm just going to graph the highlighted points. So the original function was 1, 2, and then 2, 3. I'm on the wrong side of the grid, I'm sorry. 1, 2, 2, 3, 3 and 4. Okay, 4 and 5. Whoops, sorry. 3, 4, 4, 5. Here you go, those are the 4 points. Okay, let's graph the corresponding points here. So -2, 2, -2, and 2. Okay, look at this point. It went from 1 to -2. Okay, now let's graph -1, 3. So -1 and then 1, 2, 3. This point went 3 to the left. This point went 3 to the left. 0, 4. This point went 3 to the left. 1 and 5. This point went 3 to the left. There's a transformed function. It went left by 3. Okay, so the x plus 3 plus 1, that inside caused a horizontal translation left 3. Okay, left 3. All right, so now the summary. So let's fill in the very last page. So the rule is for any linear function, if the input changes, so if you have g of x is f of x minus h, that's changing the input, the inside here, to x minus h. Okay, changing the input. Okay, changing the input. H is on the inside, therefore the input changes, meaning the y remains the same. Okay, so that's the rule. H causes a horizontal translation left to right. Okay, and it works opposite of the way you want to think. It's going to be opposite of equation. Meaning, if you have minus h, it's going to go right. If you have plus h, it's going to go left. Okay, so let's do this without filling the table, which is our end goal here, really. Excuse me. So this is the original function. You want to look for what number changed here. Okay, I see that 3 changed. Is 3 on the inside or the outside? Well, it's clearly on the inside. So it's plus 3. What's going to happen to the original function? Well, plus 3 goes to the left for horizontal. So this is going to go left by 3. So what's the value of h? It is 3. Therefore, our original function f will go left 3. Alright, that's it. Your assignment is the worksheet. And then when you start on the worksheet, the very first problem has 2 sections, and you are to graph all 3 graphs on the same line, because I want you to see how the original one, and that's the x squared. So you already have this, you already know the filling for this. So it's going to be negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that's the original function. So graph that. Then I gave you 2 different examples. I want you to graph those on the same grid. And be careful with the negative signs here. I gave you the x values. Okay, notice the x values here. Notice what you're going to get for the y values. All right, and graph it on the same graph. All right, see you tomorrow.